All right, welcome to The Explainer. Today, we're diving into the single most advanced security system on the entire planet. And you're not going to find it in some secret government bunker. Nope, it's running inside you, right now. Let's get into it.
You know what I'm talking about, right? A tiny little paper cut, and suddenly there's this whole dramatic scene. It gets red, puffy, or think about chickenpox. You get it once as a kid, and then that's it. You're set for life. These aren't just quirks. They're evidence of a hidden war happening inside you 24/7.
The answer, of course, is your immune system. And we're not going to talk about it like some boring biology lesson. For this explainer, we're treating it for what it is: an elite, hyper-intelligent security force, complete with its own ID system, first responders, special forces, and an absolutely incredible memory. So, first things first. Any security system worth its salt has one primary job: know who's a friend and who's a foe.
I mean, think about the scale of this challenge. You have trillions with a T of your own cells that all need to work together. And at the same time, any foreign invader, whether it's a tiny virus or just a splinter, has to be spotted and taken out. So how on earth does your body check ID on that massive scale?
Well, it all comes down to these proteins with a very long name, the Major Histocompatibility Complex, or MHC for short. The easiest way to think about this is like a unique molecular ID card. Every single one of your cells wears this ID on its surface, and it's basically screaming, "I'm on the team. I belong here. Don't shoot."
And if you want to see just how critical this ID system is, look no further than organ transplants. It's the ultimate test. If you get a kidney from your identical twin, the MHC IDs are a perfect match. Your body's security force checks the ID, sees it's legit, and says, "Welcome to the club." But if that kidney comes from an unrelated donor, the immune system spots that foreign ID in a second and launches an all-out attack, destroying the very organ that's supposed to save a life. That's how seriously it takes ID checks.
Okay, so the ID system is in place. But what happens when an intruder, say some bacteria from a dirty cut, actually breaches the wall? Well, that's when you dispatch the first responders.
And you know this response intimately. It's inflammation. That redness you see, that's your body literally widening the highways, your blood vessels, to rush emergency crews to the scene. The heat is just from all that extra blood flow. The swelling, that's the vessels getting a little leaky on purpose, to let defender cells flood the area. And the pain? Well, that's the system's siren, blaring to your brain, "Hey, pay attention. We got a problem down here."
Now, who are these first responders? They're cells like macrophages, and they're basically the cleanup crew. Their job is super simple. They find anything that doesn't have the right ID, and they eat it. The process is called phagocytosis. They literally attach to an invader, completely engulf it, dissolve it with powerful enzymes, and then just spit out the leftovers. It's brutal, messy, but incredibly effective for handling things right away.
But sometimes, the first responders get overwhelmed. The threat is too big, too smart. For a really serious invasion, your body has to activate the experts, the highly trained, elite special forces of your immune system.
First up, you've got your B cells. Think of these as your mobile weapons factories. Once they get the call, they start cranking out millions of these little protein missiles called antibodies. These aren't just dumb bombs either. They're like heat-seeking missiles, designed to lock onto one specific kind of enemy floating around in your blood. And then you've got the T cells. If B cells are the missile launchers, T cells are the assassins. They're built for hand-to-hand combat. And here's the crazy part. Their targets aren't the invaders themselves. Oh no. T cells hunt for your own body cells that have turned into traitors, cells that a virus has hijacked or that have become cancerous. They find them and they eliminate them. No mercy.
And you can see these special forces go to war right here in this data from a hepatitis B infection. Look at this. A healthy person has about 2,800 of these special forces cells, lymphocytes. But during an active infection, that number skyrockets to over 8,500. That's the army mobilizing. And as the virus is detected, boom, the antibody factories start production. Now here's the cool part. After recovery, the cell count goes back to normal, but look at the antibodies. They're still there, standing guard, forever.
And that is the superpower of this system: memory. The first time you get exposed to something new, the response is kind of slow and clunky. Your system has to learn the enemy, design the right weapons. In the meantime, you get sick. But the second time that same enemy shows up, oh,
It's a completely different story. The memory cells recognize it instantly. The counterattack is so fast, so massive, the invader is wiped out before you even know there was a fight. That's why you don't get chickenpox twice.
So this system is brilliant, powerful, and almost always gets it right. But it's a complex machine, and sometimes even the best security systems can make a mistake.
The first kind of failure is what you might call a false alarm. We know them as allergies. This is your immune system completely overreacting. It sees something totally harmless, like a speck of pollen or a bit of dust, and mistakes it for a 5-star, code-red threat, launching a full-scale and totally unnecessary attack.
It's a two-step glitch, really. The first time you're exposed, your body gets sensitized. It makes antibodies for this harmless thing and attaches them to special cells called mast cells. It's basically setting up thousands of tiny, invisible tripwires all over your body. So the next time that pollen comes along, it hits those tripwires, and bam, the mast cells detonate, releasing a flood of chemicals like histamine that cause all the sneezing, itching, and misery we know as allergies. But there's a much, much darker kind of failure. An insider threat. And there is no better example of this than HIV. This virus is just diabolical. It doesn't just try to sneak past security. It marches right up to the front door of the command and control center and kicks it in.
See, HIV specifically targets the generals of your immune system, the T helper cells. And this timeline just shows how devastating that is. For the first few years, the body puts up a heroic fight. The T cell count stays high, but HIV is just relentless. Year after year, it assassinates these command cells, and you can see the count start to drop, and then it falls off a cliff. Once the T cell count gets too low, the command structure is gone. The system collapses, and that's when you get AIDS, where the body is left defenseless.
Okay, that's a pretty sobering thought. But the story absolutely does not end there, because over the last century, we've gotten incredibly good at hacking our own immunity.
We basically have two main strategies. On one side, you have vaccination. This is proactive. It's like running a full dress rehearsal for your special forces. We show them a dead or weakened version of the bad guy so they can learn its face and build that powerful, long-term memory, all without you actually getting sick. On the other side, you have serotherapy. This is purely reactive. This is like calling for backup. We just inject you with a dose of pre-made antibodies. It works fast, but it's a temporary fix. One is training your own army for life, the other is borrowing an army for a day.
Which brings us to the big question we have to ask ourselves. This system, from its simple ID checks to its network of assassins and memory cells, is a masterpiece of evolution, refined over millions of years. As we get better and better at hacking it, at tweaking it with our modern tools, how do we make sure we don't accidentally break the ancient delicate balance that it relies on to keep us safe? Something to think about. Thanks for joining us on The Explainer.